The Physics of Sound, Understanding the Science of Sound Waves, written by Mark Hedges, narrated by Aria Montgomery. Chapter 1, Fundamentals of Sound Waves. Sound waves are a fundamental aspect of physics, representing mechanical vibrations that travel through a medium. Unlike electromagnetic waves, which can propagate through the vacuum of space, sound waves require a material medium such as air, water, or solid substances. These waves are generated when an object vibrates, causing nearby particles in the medium to oscillate. As these particles move back and forth, they transfer energy to adjacent particles, creating a propagating wave of compression and rarefaction. This process continues outward from the source, allowing sound to travel over distances. The two primary types of waves in physics are transverse and longitudinal waves. Sound waves fall into the category of longitudinal waves, meaning that the oscillations of the particles occur parallel to the direction of wave propagation. In contrast, transverse waves, such as water waves and electromagnetic waves, involve oscillations perpendicular to their direction of movement. In a sound wave, regions of compression correspond to areas where particles are densely packed together, while regions of rarefaction represent areas where the particles are spread apart. This alternating pattern of compression and rarefaction allows the wave to carry energy without transporting matter itself. Several key properties define sound waves and determine their behavior. One of the most important characteristics is frequency, which refers to the number of oscillations that occur per second and is measured in hertz. The frequency of a sound wave directly influences its perceived pitch, with higher frequencies corresponding to higher pitched sounds and lower frequencies associated with deeper tones. Another essential property is wavelength, which is the physical distance between successive compressions or rarefactions. Wavelength and frequency are inversely related, meaning that as one increases, the other decreases. Amplitude is another crucial characteristic of sound waves, representing the magnitude of particle displacement within the medium. A larger amplitude corresponds to greater energy in the wave and is perceived as a louder sound, while a smaller amplitude results in a quieter sound. Speed of sound varies depending on the medium through which it travels, with sound moving fastest in solids, followed by liquids, and slowest in gases. This variation occurs because the speed of sound...
Sample complete. Ready to continue?